Our solar system is 4.6 billion years old, with 4 rock-solid surface planets: Mercury, Venus, Earth, and Mars, 2 gas giants, Jupiter and Saturn, 2 ice giants, Uranus and Neptune, with a couple of dwarf planets and asteroids, of course. Even ancient civilians placed a lot of emphasis on astronomical observation, even though for them, if you think about it, back in the day, only their universe was just the sun, stars, and a couple of pointy or shiny things in the sky that were moving among the stars. Those are, of course, planets, as the Greeks have said. So this is the complete story of our solar system. I always find videos, I watch a lot of videos about our solar system, our galaxies or whatever, but they never dive deeper than I wanted to be. So they had me fooled. They had me thinking that I knew enough about our solar system. By the end of this, I promise you, you will learn a lot of interesting things that I didn't even know about our solar system. So mostly when you think about the solar system, we think about the influence of the sun. But the influence of the sun stretches beyond the planets that I've already mentioned and forms this sort of bubble, this huge bubble called the heliosphere. This bubble is created by the solar wind and a stream of charged gas blowing outward from the sun. As we are orbiting the center of the Milky Way galaxy, the heliosphere itself is orbiting with it. Like, it moves. Everything in the solar system that's influenced by our sun moves at the same time, creating this bow shape. Imagine a boat in water, right? It creates this bow shape, but the same thing happens with our heliosphere. Imagine Andromeda and our own star, the sun, right? As we crash through interstellar space and gases in our interstellar, then we reach the termination shock. The termination shock is where the solar wind, as created by this heliosphere, slows down. It's being slowed by the gas between 2 stars. Imagine Voyager 1. So Voyager 1 reached this termination shock back in 2005, and it measured a slowing effect. And then it started sending us this data, right? And for the sake of this video, I want you to imagine as if we're inside Voyager 1 or Voyager 2, whichever of the Voyagers, because we are venturing through the solar system like it did. So when it started sending us this unusual data, we were able to measure what's the slowing effect and what's causing it. As we've mentioned, it's pressure from gas between 2 stars. But with this series, we'll venture even deeper. We'll venture even deeper in places that Voyager 1 itself will take thousands of years to actually venture throughout or exit into the Oort cloud. The Oort cloud is a huge spherical shell that is made of ice bodies that's surrounding our own solar system. But let's start with the stories about Earth's atmosphere, which is mainly nitrogen and oxygen. Mercury's very thin atmosphere, while Venus is very thick atmosphere, which is mainly carbon dioxide, and Mars as well has a very thin carbon dioxide atmosphere, and Jupiter and Saturn are mostly hydrogen and helium like the sun. We have Uranus and Neptune, which are mainly made of water, ammonia, and methane with ice metals, right? But how you say it, and ice metals around their core. We have the comet Sirius and the outer dwarf planets, which are composed of similar stuff. This is Pluto, Iris, Haumea, and Makemake. Is it Makemake? I'll call it Makemake after Makobe. Found a similar composition, which is solid with the icy surface. And then we move to the moons, the rings, and magnetic fields, which characterize these planets. With 145 planetary moons, excluding the 6 from the dwarf planets, with Pluto's 2, Iris 1, and Haumea 2. I'm not even sure that I'm pronouncing Haumea correctly, but it's whatever. Someone will correct me, of course. These moons, of course, these planetary moons are not the same, but the standouts, the ones that stand out, is Saturn's Titan, that has a very thick atmosphere, and Jupiter's Io, which is the most volcanic space, or the most volcanic body in the entire solar system. Look at the Stonehenges in the UK. Many ancient cultures have actually built similar structures that they want to mark the movement of the sun and the moon. And our stars inspired a lot of mythological stories from all over, like ancient cultures like the Egyptians, Aztecs from Mexico, Native American tribes, and the Chinese. Many of these cultures believe that the Earth is stationary, right? So this is what most cultures believe, but now we know what's going on. I think it's just the ego that everything revolved around them. The sun actually is the central point of our solar system, of course, and it's this huge sphere that's made of mostly ionized gas, and it supports life on Earth. I think that's the best way to explain it. The connection that we have between the Earth and the sun is what drives ocean currents, seasons, weather, and climate. So the sun is held together, of course, by this huge gravitational attraction that's producing big pressure and temperature at the core of the sun. So if I explain the sun, I think we have to divide it in 6 different regions. I think this is much simpler. The core, the radioactive zone, the connective zone, the visible surface that we call the photosphere, and then we have the chromosphere and the outermost region that is called the corona. So these are the 6 regions that actually make up the sun. Things that are always found interesting are these spots. They are called sunspots in the photospheres I've mentioned. So these areas are a strong magnetic field areas that are cooler, and since they are cooler, they are darker than all the surrounding areas. Of course, they fluctuate over time, and with this solar cycling, it creates solar flares. People that are studying astrophysics, they go crazy for solar flares, of course. So when people started applying the laws of physics that were created by Newton on planets, when they started applying them on planets, Mercury didn't follow these laws of Newton. So since Mercury is so close to the sun, we can't observe it. It's very hard for us to observe it from Earth, except maybe when there's a twilight that's blocking sun's view as much as possible. But now we have photographed enough and we know enough. So instead of having an atmosphere, Mercury has an exosphere made up of atoms blasted off from the surface by the solar wind since it's so close to the sun. It's also created by the striking of micrometeorites. Mercury looks more like our moon based on the collisions with meteorites and comets, so it has impact craters like our moon. So we've sent a spacecraft, Mirena 10. This was the first spacecraft to actually visit Mercury. In 1991, we used the radar to show that Mercury may contain water in its north and south poles. Quickly write in the comments what you think the answer is. What do you think someone from Venus is called? Right, I'll give you a second. So the people from Venus, if like there's an alien species in Venus, is called venereal. These are sexually transmitted diseases. We call them venereal diseases, based on, since Venus is the planet of love, it's the goddess of love, we say these diseases are from Venus, but of course they are not. But I think it's an interesting take on something that we view as so disgusting, and we place it all on Venus. Venus and Earth are very similar. They are very similar in size, mass density, composition, and gravity. And then the similarities stop right there. Venus has a very thick and rapidly spinning atmosphere that's creating a world that's hot enough to actually melt lead. Lead doesn't melt, but when it's inside of Venus, it melts very quickly. So the atmosphere consists of carbon dioxide, clouds of sulfuric acid droplets, and a trace of water. I think all these planets of water, all these planets will find there's a trace of water. And now recently there have been speculation about microorganisms possibly living on the atmosphere of Venus because of some substances that have been observed that are currently in the atmosphere. For Earth, I want you to go watch this video of why Earth is so well designed, and for the moon, I want you to watch why we should go back to the moon. The most interesting planet lately has been Mars, because billionaires and government have been planning to colonize it for like a while now. From a planet that was thought to be dead when we first imaged it using Mariner 4, it has shown us to be a very complex member of our own solar system, having a lot of mysteries that we are yet to solve. For a while, we thought that these bright and dark areas were actually patches of vegetation, and that Mars could possibly likely be a place for life forms, since we thought that there could be water on Mars. And now with the latest technology and observations that we've done, I think in 2019. We know that there is water on Mars, so the possibility of there being life has increased. That's why we keep sending probes and Mars rovers to actually study it more and find out more on what's going on Mars. Then we have to talk about the asteroid that can cause mass extinctions, as we've seen with the dinosaurs. There are a lot of people that right now are worried about asteroids, and they are making missions like the Dutch mission by NASA and other missions currently being developed so that we are able to deflect asteroids as they're coming through Earth. These asteroids are small rocky fragments left from the formation of our own solar system. Most of them are found orbiting the Sun between Mars and Jupiter, so this is called the asteroid belt. This is when Jupiter was formed. It stopped the formation of other planets between it and Mars and leaving these small rocks in between that we call asteroids. And I've told the story about my first time seeing a shooting star in this video. Go check it out. Meteors are bits of interplanetary materials falling through Earth's atmosphere and being heated up as they go through, giving us this glowing dopeness. And meteorites are when they are flying through space. It's when they are not in our atmosphere, and they become meteors when they enter our atmosphere for those few seconds as they are creating this glowing trail. And then we have the moons. As I've mentioned, we have 145 planetary moons in our solar system, but I would dive deeper on these details as I'm talking about planets like Jupiter and Saturn. So most of these satellites, moons or satellites, are formed from disks of gas and dust circulating around planets during the early solar system. So this is the first part, and then wait for the second part about Jupiter and its moons, Saturn and its moons, and everything in our solar system. I think we're going to do a 3-parter, so like and subscribe. I never say like and subscribe.